Stephen, it is Hot Chips 2023 this week, and we have a lot of news stories that have come out of it. Intel has unveiled the Sierra Forest and Granite Rapids Xeon processors targeting data centers. Sierra Forest is Intel's first E-core Xeon with 144 CPU cores, while Granite Rapids focuses on core performance. ARM has introduced Neoverse Compute Subsystem, aiding Neoverse into core integration. AMD has previewed the Sienna EPYC processors for edge computing with up to 64 cores, notable power efficiency, and a compact form, catering to the edge computing market's demands. So we're going to run down these stories in a little bit of a closer look. Let's start with the Intel story. We talked about Sierra Forest and Granite Rapids. Sierra Forest is built on Intel's 3-process node. Like we said, it's their first E-core Xeon for data centers. Granite Rapids employs all P cores. Both chips do share the same platform, which supports up to 12 memory channels, introducing Multiplexer Combined Ranks of DIMM memory. And then Sierra Forest boasts 144 CPU cores, as we mentioned. The Granite Rapids is focusing on core performance. And I think that this is really Intel's move into trying to gain market dominance in the data center once again. Stephen, what do you think about these new CPUs from Intel?
Yeah, this is the whole ball game for Intel, isn't it? Basically, Intel is planting flag here, saying Xeon is back, baby, and that's really what we're seeing with these processors. So let's talk a little bit about the differences here. First off, there are 2 Xeon platforms that are being talked about as the next generation Xeon platforms. This is important, but that being said, all of these platforms fit into Intel's strategy of chiplet-based computing, which means that we could see some mixing and matching. In fact, we probably will see some mixing and matching and a whole world of different processors that will come out of this. So let's start with Granite Rapids because it's the easiest one to understand. Essentially, this is the next generation after Sapphire Rapids. It incorporates the latest Intel performance, high performance cores with multi-threading, all the new features, everything. This is the all singing, all dancing, big bad Intel Xeon that you're expecting. And it will include a lot of stuff. Now, this is sort of an early preview of Granite Rapids, though it is expected to be delivered in 2024. Essentially, it's got all the good stuff. The Redwood Cove P cores that are used in Granite Rapids have their lower latency, they have better branch prediction, prefetching, memory encryption, all sorts of good stuff built into them. We expect the final processors to include a lot more I/O, PCIe 5, CXL2, or maybe 3 support, all sorts of stuff, and to be delivered on a chiplet-based architecture, which means that Intel will be able to basically develop chips that have the right number of cores and then the right number of supporting I/O components to meet the demands of the data center. Granite is going to take the place of for multi-CPU as well. We expect to see these things in data centers with up to 8 processors in NUMA nodes and that sort of thing. So really, when you hear Granite, think next generation Xeon. This is the thing I know. This is the thing I am using today, and this one's going to be bigger, badder, faster, etc. Now, Sierra Forest is a different animal entirely, and an interesting animal. First off, we expect to see a new server platform built around this called Birchstream. Sierra Forest, Birchstream, man, I want to live there. The reason that we've got all these, let's say, pleasant code names is because Sierra Forest is built around Intel's E-core, not the P-core. This is really cool. This is something that all of us who've been watching the industry have wanted to see. If you remember, a few years back, Intel introduced sort of a performance core, efficiency core kind of thing, which is very similar to what you're seeing on the ARM side. For example, Apple's M1 processors have performance cores and efficiency cores. So do a lot of smartphone processors. AMD took a little bit of a different direction with this, with their Zen 4 and 4C cores, in that the Bergamo, which is their sort of answer to the E-core, is more of a stripped down version of their performance core instead of a whole new core. Intel's E-cores, on the other hand, are much stripped down. They are very different from the P-cores. They, for example, don't support hyperthreading. So if you've got one core, you've got one thread running. They do now support some of the more advanced instructions that Intel is delivering. At least they will in the Sierra Forest generation. And a lot of us, when we saw Intel introduce these E-cores, which are physically more compact than the P-cores, we were like, man, it would be cool if Intel delivered a super duper Xeon with lots of those instead of, kind of having it all be on the performance side. That's Sierra Forest. Essentially, we're expecting to see as many as 144 cores per processor running on Sierra Forest in the first half, or maybe a little later, of next year. And essentially, this will give Intel bragging rights in terms of the number of physical processor cores per socket. It will also probably deliver quite a lot of performance because, of course, these things will be built on Intel's next process node. As I said, the wide expectation is that they're going to support most of the advanced instructions that Intel has introduced recently in terms of accelerators, and that these processors will really be up to date in terms of the I/O aspect as well. So again, PCIe 5 and CXL and things like that. Because again, these are built on chiplet approach, and the chiplet approach means that you can have a supporting I/O chip that gives the processor a lot of capability here. So, in summary, Intel is kind of going in two directions with the next generation Xeon. They've got Granite Rapids, which is the big bad multi-processor, does everything with the P cores. And then they've got Sierra Forest, which is kind of a different animal, a little bit more light and nimble and low power. And so it's going to be interesting to see how AMD reacts to this and how these things compete against the rise of ARM and, yes, RISC-V in the data center.
I will say, Stephen, that I think that the reason why Intel has decided to do this is thanks to the cloud and the fact that we're starting to see a lot of cloud management technology kind of filtering down into the on-prem data center. Because when you think about it, there's two ways that you want to run these things. You either want to run them flat out and feed it as much as you can to get all that number crunching going, or you want something that just kind of maintains things in the background and it runs those workloads that don't need to ramp really fast. But you would want that to be as efficient as possible in the amount of rack space that you have in a data center. And I think that those kinds of mentalities are starting to drive chip development, because when you think about making AWS instances, you can have the big honking ones, but you don't want to run them very long because they're expensive. Or if you have things that just need to exist out there and do stuff, I mean, you can make those relatively cheap. So, companies that are looking to do that kind of, cost allocation can buy a few of these Sierra Forest machines. And basically, because they can, they have so many cores, they can effectively part them out from a time sharing perspective or a virtualization perspective, and really cost allocate them efficiently. And then, if you need something that has to run really, really fast, hey, we've got the Granite Rapids machines over here that will do that for you. So I'm glad to see that someone at Intel has kind of woken up and said, we can't just keep building the biggest, strongest, fastest chips. We also have to address the part of the market that needs, I don't know, the Toyota Camry of servers.